Good morning. Thank you so much for coming to my talk. This morning I'm going to be talking about teaching kids about artificial intelligence, about machine learning. There's two things I want to cover. I want to talk about why I think it's really important that we do it. I'll spend a few minutes on that. And then I want to talk about how we can do it. I'm going to show you some projects that kids at local schools to where I work have made, and I'll talk a bit about the experiences of trying to get kids to build these things. So, kids' impressions of AI. What do they think AI means? What image do they get when you start talking to them about artificial intelligence? At best, it's things like this. At worst, it's things like this. I think it's really important that we try and give kids a better picture of what AI means. For a couple of reasons. Partly because AI is all around us. We all use machine learning systems every day. Whether it's the spam filters that learn to recognize what a spam email looks like, or the recommendation engines that recommend the films we might want to watch, or the music we might want to listen to, or the predictive keyboards that learn what we might want to type next, or the assistants we use, or the translation systems we use. The point is, if part of education is teaching kids how the world around them works, then I think introducing them to the idea of AI and machine learning has to be a key part of that. But it's not just about how the world works today, it's about helping kids prepare for debates about what the world should be like tomorrow. If we're going to enable kids to be able to engage in the debates about how AI should be used in the diagnosis and treatments of our major illnesses, or in driving the cars and trucks on our roads, then we need to give them that grounding of the fundamentals of how this technology behaves, how it's trained, how it works. So that's all the why I think it's important that we do this. But I want to spend most of my time going through demos. Now, you might have seen Scratch before. Scratch is widely used in schools and coding clubs as a way of introducing code and programming to kids. What you get is this sort of palette of blocks representing programming fundamentals, and the kids drag it onto this canvas here where they snap them together. And that dragging and snapping together is coding. It's essentially a programming language, and this is how we explain coding to kids. Particularly in the UK, but worldwide, this is, at primary school level, an introduction to coding. So this is what I've been starting with. How can we take this environment and this platform and this language that kids are already familiar with and start extending it so that they can start learning about machine learning and AI? So this is the platform that all my demos are going to be based on. So it's project-based. So the idea is that kids will create a new project for every new thing they're going to try and make. So with this one, it's about trying to make an assistant, a smart assistant, something that can be trained to recognize commands to turn things on and off. So they're going to create a project, and they're going to train the computer to learn how to recognize the meaning of text. So then going into that, the idea is that the tool takes the kids through the three main phases of a machine learning project. Collecting examples that they're going to use to train a machine learning model, using those examples to train the machine learning model, and then using that model in Scratch to make an app, a game, a project. So starting with train, they need to collect examples of what they want the computer to learn how to recognize. So for this one, it's that fan and that lamp that I showed you a moment ago. So they need to create buckets of the kinds of things that they want to train the computer how to recognize. So how to turn a fan on, how to turn a fan off, how to turn a lamp on, and how to turn a lamp off. So for this simple first example, we'll just have these 4 buckets. And then what they need to do is with this add example button at the bottom, they need to type in examples of how they would ask each one. So in here, they're going to type in examples like, please can you turn the fan on? Let's have the fan on now. Please switch the fan on for me. It's too hot in here. Let's have some air, that sort of thing. Now, this one is after they've been training for quite a while. You only need like 5 or 6 examples in each bucket to get started. So having done this, you use these examples to train a machine learning model. So going back into, skipping ahead to Scratch, that model that the kids have trained themselves shows up as new blocks in the palette for them to work with. And then you can see here, this sort of one I prepared earlier, this is what the script looks like. So it gets the kids to type in a command. It uses their model to recognize it, and depending on what it's recognized it as, it will animate the right device. So, for example, that means that now they can type in, I'm hot, can we turn on the fan? And even if that wasn't one of the examples they've given it, if they hadn't phrased it that way before, from the examples they'd given it, it has learnt enough to be able to recognize the intent behind that command, and it can do the right thing. This is something that I've done in primary schools, kids can do in 40 or so minutes, including making the animation and stuff. So they've made their first assistant. Now, if I'm doing it in secondary schools, I'll take it a bit further. So I'll look at confidence scores. The machine learning model won't just return the class that it's recognized the text as, but the confidence in how likely that it is to be correct. So, they can put a simple comparison. If the confidence is bigger than 70%, just plucking a number out of the air, then yes, do the thing. Otherwise, say, I don't know what you mean. So that means, yes, it still works. You can still tell it to turn something on or off. But it means if you say something, I think in this example it says, make me a cheese sandwich. Instead of blindly turning a fan on or off, it will say, I don't know what you mean. The point is that very quickly, instead of Google Homes or Amazon Alexas or Siris or Cortanas, instead of them being this magic black box that sits in the corner of the room that just magically knows what they mean, they've made a simple one for themselves. The steps they go through of, predict what commands the user might give, collect examples of those commands, of how they would be phrased in natural language, use those examples to train a machine learning model, and then script what you want the app to do in response to what it's recognized. I mean, those are the phases we go through when we do customer projects for things like assistants and chatbots. And it's something that primary school kids can build for themselves in a single lesson. So that's fundamentally what I'm trying to do here, but I'll show you a few other examples of how this can work. This one was a fun one. This was making a chatbot about, this one is about owls. So they did this as a class. So between them, they came up with ideas of what sorts of things they were going to research about owls, what sort of things they thought people might ask, like what sort of foods do owls eat, whereabouts in the world do they live, how long do they live for, how many species of owls are there, how big do they get. And then they each had to go away and add some examples in for how you would ask that kind of question, and they ended up with something like this. So 6 examples of each, how long do you live, how old can owls get, how long can an owl live, and so on. And then they made this, slightly more complex than the last one, but the same basic idea. Take a command from the user, and here they did their research into owls to put the answers in the script so the owl can give the right answer. So what they made is something that they can ask questions about owls, and it will tell you anything you want to know. Now, I've done this project with several classes now. Sometimes they do it based on what they're already studying in lessons. So I've had classes make chatbots about Vikings, where it answers, what do you wear, what did you eat, Romans. One really good one, they made like a school prospectus. So they made it about their own school. So it was a chatbot that prospective parents and prospective students could ask questions about, and they trained it to answer questions about what it's like to go to school there, what the canteen's like, what the food's like, that sort of thing, what the teachers are like. That was risky. What's the next? I've forgotten what my next demo is. Sorting Hat. They like this one. I hope some of you have seen Harry Potter before or read the books. Otherwise, you won't understand what I'm talking about for the next minute. I get them to create buckets for examples of things that characters in Harry Potter say. The students from the school in Harry Potter. So Gryffindor, Hufflepuff, Ravenclaw, and Slytherin. And then what they have to do is to go through the books and pick out quotes, examples to put in each of these buckets. Now, when I'm doing this with secondary school kids, they will often type this in themselves. With primary school kids, it's easier to give them examples, quotes they can copy-paste. But the idea is that the reason we use this is the use of the houses have quite distinct personalities, and that shows up in their dialogue. There are quite distinct character traits that show up in each of the houses. And that shows up in the classifier that they train. So they're training, what they see is it's not just about training it to recognize the meaning of text, but recognizing the tone, the sentiment, the character. So this is my attempt. This wasn't a kid's attempt. This is my drawing of a hat. It's clearly a hat, whatever you might think it looks like. And then they pick out another quote that they hadn't trained it on, and to see whether or not the hat properly recognizes what house that character is from. Or what they like to do is type in things their teachers say and see what house their teacher would be in. This works well with younger kids, but this idea of training a machine to recognize the use of language, there's a lot you can do with that with older kids. So with secondary school students, I tend to use media as a source of language and make it part of what they're already studying about the different use of language in different media. So by that I mean stuff like taking newspaper articles and training a machine learning model to recognize, given an article, what newspaper that probably came from, because different newspapers have different styles. In this demo, to keep it short and simple, it's just looking at headlines. But actually, it turns out you can train a classifier to recognize headline text pretty well as well. So they pick a few national newspapers, and then they have to collect examples of headlines from each of these newspapers that they type into each of these buckets. Now, you don't have to get them to collect stacks of newspapers. There's tons of sites online which will have archives of every front page of every national newspaper going back to years, so they can just go through and pick a bunch of examples. And the kinds of things the classifier is going to pick up on are, some of them are really short, 1, 2, maybe 3 words. Some tend to be sentences. Some tend to be all caps. Some are sentence case. Some tend to be very emotive. Some more matter of fact. Some have particular topics that keep coming up. Some newspapers have particular themes and topics that they'll regularly put on the front page. These are all the kinds of things that the machine learning model they train is going to be picking up on. So then they'll make things like this. I mean, this is one that actually, they spent quite a while on this one. They made essentially like a test framework in Scratch. So what this is they picked 10 new headlines that they hadn't trained it on from each newspaper, and the color is color-coded. And then the blocks are what the machine learning model recognized it as. So partly it was a way they could see how accurate their model is as they started to train it. But the other interesting thing was, actually, it was a really interesting discussion with them about the ones it got wrong. So you can see there, for the 10 headlines they picked from The Independent, 7 of them it got right, 2 of them it thought were from The Guardian. You could start to see, actually, the similarity between maybe the broadsheets and the red tops in the test results that they were getting. But so it's not just about sort of getting them to learn about AI or build things in AI just for the sake of that, but as in this case, part of a broader discussion about media literacy. Going back to projects that work with primary school kids, this one's a fun one. Sentiment analysis, essentially they're learning. I get them to make 2 buckets and type in the kindest compliments they can think of here and the meanest insults they can think of here. Risky. With primary school kids, poo tends to be as bad as it gets. Secondary school, it gets a little more flowery. But then what they make is, using these examples, they make a character in Scratch that can respond to compliments and insults. So they make a face like this, they give it a few different facial expressions, and then the script to do this is actually really simple. It's something that I've had sort of 6 and 7-year-olds making in a lesson, because all they need to do is get it to type in a message, run it through the classifier, and based on how it's classified, the face can react. See, I've got way too long a video here, so I'm going to skip this forward a minute. No, I can't. That's too much coordination. Oh, never mind. With secondary school kids, the interesting thing, I still do this one, but you can talk about where the limitations of this kind of approach are. What are the things it's going to get wrong? Talk to them about why it's difficult for social networks to properly enforce restrictions on trolling or abuse. And, what are the things it can recognize and what can't it recognize? What's an appropriate use of this kind of thing? Here we go. So you can say, I think you are an amazing person, and then she smiles. Or you can say something mean and make her cry. And inevitably, these lessons tend to become an exercise in what can we say to make her cry? I hate you and I think you smell bad. Boo-hoo. So, quick recap. So, you can get kids to train a machine learning model to recognize text and to see for themselves the different kinds of applications that are possible here. Whether it's stuff like chatbots to recognize the intent, the meaning of some text, or the use of language and the style and tone, whether that's for the younger kids something like sorting hat, personality quiz style, put you in a bucket sort of thing, or for the older kids something about looking at use of language in different sources. And finally, with the face, the happy, sad one, looking at sentiment analysis. But it's not just about text. There's also a ton of other sorts of projects you can do. Numbers are an interesting one. There's a load of games you can make if you train a machine learning model to recognize numbers. So, for example, a really simple version of Pac-Man made in Scratch. This is me playing. This is me playing Pac-Man. One ghost and no obstacles in the way. But I have to press the arrow keys to move the Pac-Man character around the maze and avoid the ghost. Now, even at a primary school level, they can understand that you can represent the state of the game at any point as a couple of coordinates. And also any decision that Pac-Man needs to make, he's got one of 4 decisions to make. He can go up, down, left, or right. So that means when you're training it, what you want to do is at every point in the game, like when Pac-Man was there and the ghost was there, 4 numbers, and I decided the best thing to do was to go up. Or when Pac-Man was there and the ghost was there, I decided to go down. So to train their model, they need to collect lots of examples of this, 4 numbers and a decision. Now, you don't want them typing that in. That'd be really laborious. So the best way of doing, once they've set up their 4 buckets to collect their training examples, they make a game in Scratch to collect that training data. So what they do is, come on, move on. One of the blocks that gets added is to add training data. So they make the game in Scratch, and you can just about see here that it's when they press keys, when they press right, it goes right. When they press left, it goes left. But as well as controlling Pac-Man, they're adding to that bucket of training data. So they're training Pac-Man by playing the game. And that's actually a really good lesson to see that not all supervised learning needs to be manually labeling data, that collecting training data as a byproduct of something you're doing otherwise is a really effective way of training AI systems. So even just from playing that briefly, you could sort of see that when Pac-Man was there and the ghost was there, I pressed the down key. So I get them to play the game for a while, and before long, they've collected tons of training data. It's often hard to stop them training Pac-Man. But then they switch the script. So instead of them controlling Pac-Man with the arrow keys, the machine learning model gets to do it. So then they tweak their script, and then they set it off again. And this time, Pac-Man's playing itself. And it's really cool because you'll get 2 kids sat next to each other. Their Pac-Man will behave differently based on the different ways that they trained it. You've always got like one that realizes they can do laps of the board and always stay ahead of the ghost. And there's always some that realize if they get right up close to the ghost and keep switching places with it, they can avoid it forever. And that's reflected in the behavior of the system they've trained. Or even just things like, they know from having built the script that they haven't put anywhere in here to tell Pac-Man that the objective is to avoid the ghost. It's behaving like that because that's how it was trained. It's not following rules to do that. That kind of thing, that once kids have done it for themselves, that have that penny dropping moment is really effective. And to learn about use of AI in games, to learn about that idea of how we can train machine learning models. Games are a really good one. And this is a slightly more complex one that I'll do with secondary school kids. Noughts and crosses. At any point in the game, there are 9 decisions instead of the 4. But essentially, it's the same thing. What's the state of the board? It's multiple choice. What's in every cell? And then what decision did you make? And again, you don't want them to have to do lots of typing in. So the way they train it is by building a noughts and crosses game in Scratch that as they play is adding to those training buckets. And again, so they're not building in the rules for noughts and crosses into the Scratch script. They're not cheating by telling it how to play. It's learning based on the training they give it. And because I get them to do it sort of incrementally, a bit of training and then play, and it's rubbish. Bit more training, that's starting to get a bit better. A bit more training, and they see the more training they give it, the better and better it gets. They start to stumble for themselves upon lessons like the more training data you give a machine learning model, the better the accuracy. But without me having to tell them that as a rule, they experience that. They learn that for themselves. So this is what it looks like after you've collected loads. And then this is the Scratch script modified so that now the game is in, the machine learning model is driving the game. And they do, like within a lesson or two, they can get this to the point where if it doesn't beat them every game, it'll at least force a draw. The nice thing I like about this project is it's a really old idea, so I can talk about history. If you're not aware, what that Scratch project is, it's basically implementing what Donald Mitchie designed in the 60s. He was a Bletchley Park AI researcher back in the day. And he invented a machine learning model for training noughts and crosses boards using matchboxes, hundreds of matchboxes. Each possible state of the board is represented by a matchbox, and the training was adding and removing colored beads. And all that I'm doing is getting them to make that in Scratch. So it's nice to be able to tell them a bit of history as well. I won't labour this point. This is the same sort of thing again. This is top trumps. So what they're doing is they're given 5 numbers. This one is based on kings and queens of England. Like I say, trying to fit it in with whatever they're studying at the time works well. And then again, initially the computer's choosing at random. It's getting a lot wrong. It learns by playing against the kids. The more they play, the better it gets. And they're collecting the training examples of, when they had these values on the card, they made that choice, and they won, or they lost, or they drew. So you can train a computer to recognize text. They can train a computer to recognize sets of numbers. Images tend to be really fun. Image recognition is, particularly with the younger kids, where they will maybe struggle with a lot of typing. Projects where you're teaching the computer to recognize pictures has a really impactful way of making them learn some of the lessons. So often what I'll start with is just getting them to build a photo tag or a photo sorter. So I'll tell them, I'm going to give you a pile of photos. Every photo I give you is going to have either, for example, a car or a cup. And what I want you to do is train the computer to sort them out into 2 separate piles. So how are they going to do that? Well, they need to create a classifier that can recognize a car or a cup. So they create their 2 buckets, and then they need to collect examples of each. Easiest way to do that is just to find photos on the web and drag it into the right bucket. With this one, I found that they need about 10 examples in each bucket for it to start working. And that doesn't take too long. But they will often do this really quickly. I pick different objects each time, but it's fairly random what I tend to go with. So that's what it looks like after a little while. And then they use that in Scratch. So like I say, I'm going to give them a stack of photos that I haven't sort of shown them ahead of time. And then their Scratch script has to, if it's a car, put it on one side. If it's a cup, put it on the other side. So the script is this simple. Go through each one in turn. If it recognizes it there, move it that way. Otherwise, move it that way. And again, they sort of stumble onto lessons like particularly with the younger boys. When I've done car or cup, they'll always pick really sleek sports cars. So they'll train a classifier that can recognize a sports car, but not many other types of cars. But it's good when that sort of thing happens, because you can ask them, well, why do you think, why is it not recognized this SUV? Oh, well, I haven't taught it what that looks like. I haven't shown it examples like that. Okay, so how can we fix that? Oh, I need more examples. Or even just, like where maybe I hear cup, I think coffee, because I'm a developer. Kids maybe trained it with other types of cups, beakers or whatever. So it's that idea of overfitting and the similarity of your training data to your test data, although I wouldn't raise it in those terms, even the younger kids will sort of learn those lessons for themselves. And the nice thing is, again, as with all of these, the idea is to try and show them real-world use of AI. So any time kids have used a photo tagger, something that, when they upload a photo, automatically tags it, or a search engine that can search based on what's in a photo, they've used a system like this. And for them to be able to train one themselves and to see how it behaves and how it gets better the more they train it is really powerful. But it's nice to not make everything too digital. It's nice to have some real-world side of things. So, for example, using the webcam is a really nice way of collecting training data. So with this one, I get them to make playing cards, just like paper and felt pen, and hold it up to the webcam to train a computer to recognize different shapes. So with this one, just to keep it short, I just sort of got them to make 4 cards, a heart, a diamond, a spade, and a club. And then using the webcam button at the bottom to collect their training data. So they hold their card up to the webcam and then click the add button. And then again, they need sort of 10 or so examples of each of these to be able to train it to recognize what a card looks like. So it looks like that after 5-10 minutes. And then they make something like this in Scratch, a game where the computer will pick a random card, pick a random one, and then they have to hold up a card, use the webcam to recognize it, and then the computer can work out whether or not it matches. The ones who will get through it super quick, you can try and trip them up a bit, like what happens if you hold it upside down and it doesn't get so good then? Well, how can you improve that? Oh, well, if in my training data I had lots of examples upside down and on its side, then it gets better. Yes, it does. Variability in training data leads to increased accuracy. Yeah, they don't phrase it like that, but they see that behavior by themselves. The other version of this that I do sometimes is rock, paper, scissors. Same kind of idea, but instead of getting them to make something on paper, they're taking pictures of their hands. So they're training the computer to learn how to play rock, paper, scissors against them by holding their hand up to the webcam in the different shapes of rock and scissors and paper. And again, there's always a couple of keen kids in the class who will absolutely fly through this, who will hold their hand up still in front of the webcam and just hammer the take picture button and end up with 10 almost identical pictures. And then what they find is that their accuracy isn't very good. Their machine learning model it's overfitted, it's really brittle. So you can show them this by testing them to hold either the hand a different side, different distance away from the camera, or at a different angle, different perspective, and it gets things wrong. And you sort of ask them, well, why is it? And they'll often sort of suggest for themselves, well, if I gave it 10 really different photos in every different position, every different angle, every different orientation, will it learn better? Well, try it and see. And yes, it often does. So this is what it will look like initially. And then the actual game is almost identical to Snap. The computer picks at random, they hold their hand up to the webcam, and the computer can tell whether or not they've won. And if they've got time, they can use the recognizing numbers model as well, have 2 models in the project, and actually teach the computer how to make a better choice. But it's not just about recognizing what is in a picture. This one's really cool. This one is based on the phrase judging a book by its cover. So I get them to see that you can train a classifier, a machine learning model, to recognize styles of picture. So I get them to pick a few genres of books. So in this one, sci-fi, thriller, children's, and romance. And like before, they're going to collect this from the web. I mean, if you can find a book retailer or library that already has the books characterized by genre, it's super easy. You just then grab the top 10 into each one and drag it across. So pretty quickly, they can come up with a set of sci-fi books, thriller books. The smart ones always pick cookery books. Those are really easy to spot. But they end up with something like this pretty quickly. And the point is, there isn't the same thing in each of these books. They're not training it to recognize a unicorn or a log or whatever. The machine learning model will be picking up on stuff like the color palette that's used. It's going to be picking up on fonts. Like, for example, the fact that in thriller books you get those really big, bold sans serif fonts, often like where the author's name is. That romance books have a more pastel-y color palette, that sort of thing. And then with this one, what they made was a game where they could test whether or not one of their classmates was as good as the computer they'd trained to recognize new books. And it's really powerful for them just to see that this sort of thing is possible. And also, again, like I was saying, in terms of if you can fit it in with what they're already doing. So if you can get them to think about how different genres have consistent styles, and you can do this with magazine covers, movie posters, do sci-fi thriller movie posters have a consistent recognizable style compared with historical dramas, for example. So there's lots of ways you can tweak it to make it fit with what they're doing in school. But to try and include that element where they're training a computer and seeing how the computer behaves at doing this kind of job is really cool. Handwriting recognition. I like this one. So this one, I'm getting them to draw their examples directly onto the screen on an on-screen canvas. So they're training a computer to recognize postcodes. Now, the interest of fitting it into a single lesson, not the whole postcode, just the first couple of characters, and not every postcode in the country, just 3 of them. This makes it something that can be trained in 20 minutes, 30 minutes at most. So what they're going to do is to train it to recognize their handwriting, and then they make a Postman Pat game in Scratch. So what they do is they make something like this, where they have an envelope with a space for a postcode. They draw on a new postcode, and then the envelope will be sorted and go to the right van to go to the right sorting office. As I said before, I like trying to get the kids to learn about real-world uses of AI. So being able to not only let them build this for themselves and see how it behaves, but actually being able to talk to them about, well, this is how large sorting offices do automate sorting of mail. That what you've done, if you trained it on the whole postcode instead of just a bit, if you trained it on all postcodes instead of just a few, you've essentially done what we have to do in the real world. And that's really powerful. And again, if you can sort of show them examples of how variability has an impact. So, for example, the one who finishes first, and it works with their handwriting, and then you pick someone in the class who's got really different handwriting, get them to test it, and it doesn't work so well, and you sort of encourage them to think about, well, why hasn't it worked? Like, what could we do to make it better? Oh, well, if instead of just training it with my writing, if I trained it on their writing as well, it would. Oh, let's try that and see. And what you can do is get all of the kids working in the same project. So you've got 30 kids worth of examples in the same set of buckets. And then you end up with a machine learning model that's much, much better at coping with variation in writing. Where's Wally? This is a nice one. So this is not just this is taking that ability to recognize what an object is and mixing in some image pre-processing. So if you're not familiar with Where's Wally, it's that game, character hiding in a random picture. So what I get them to make in Scratch is a game where it picks a random background, picks a random set of cartoon characters and shuffles them around, and each one picks a random size and orientation and pose. And what they need to do is train it to find the cat, because the cat is Wally in this game. So the game they make in Scratch is a little bit complicated, takes a little bit of a while, but they can make it collect training data by clicking on where the cat is. That's an example of Wally. And then clicking an example of anything else, that's an example of not Wally. And you can sort of see that it's sort of cutting their overall screen up into a 3x4 grid. So it's really quick for them to collect a bunch of training examples. So I'll show you another one. So where's Wally? He's up there. And like you can see, a different background. He's facing a different way, different smiling or not smiling, and so on. And then pick a different. This time we'll go for that bit of dinosaur head. So before too long, you end up with this kind of thing. Lots of examples of Wally in different poses in different places. Lots of examples of not Wally, different poses, different places. So then to use that is essentially that same idea of chop that picture, make a random picture, chop it up into a grid, and then run every grid square through a machine learning model. And the one that gets recognized as Wally instead of not Wally, he must be somewhere in there. Now, apart from the fact that, it's a nice way of making a fun game and it works pretty well and it works pretty quickly, that idea of combining image classification with pre-processing is really common. We use that a lot in real-world projects. That means I can talk to the kids about projects that we did, like this was California in 2015 when they had a really major drought. And they needed to understand the water usage across the state in a hurry, and California is huge. So what they did is they took satellite imagery, cut it up into grid squares, and ran each one through a classifier that was trained to recognize different land use, swimming pools, lawns, that sort of thing. So really quickly, they were able to come up with a decent estimation of the water usage, land usage, across the whole state at a time of emergency when they didn't have time to do it through manual census or survey. Or even things like where we do, drones taking high-res photos of roofs, and cutting up into squares, and the classifier trained to recognize roof tile damage and that sort of thing. So it's this idea that what the kids are building in the classroom isn't totally abstract. It's based on things that we do in the real world. So recap: training it to recognize text in different ways, in different uses, sets of numbers, different types of pictures, and this is recognizing objects, recognizing visual style like the book covers, recognizing handwriting, OCR. And finally, using pre-processing to find an object in a larger picture. But my favorite projects, and often you sort of stumble onto them accidentally, but I like doing projects with the kids where it's trying to get them to explore some of the challenges of using AI. So I have to sort of nudge them towards getting things wrong and then let them see that they've done something wrong. So this was training an image classifier to recognize a lemon or a grapefruit. And up until then, most of them hadn't seen anything. This is going to work. This is going well. Photos of a lemon, photos of grapefruit. So then they put it in Scratch, and they had their photos of each. And they needed to see if the computer could properly recognize the lemon and properly recognize the grapefruit. And of course, it got it wrong. And for a lot of kids who've sort of grown up with this idea that the AI is magic and smart AI will always get something right, it going, that looks like a lemon, often they're really surprised at first. And then you sort of show them side by side, well, this is what you told it a lemon looks like. Why did it think that was a lemon? And almost all of them will go, I see, yeah, because it's light cream background, that one was dark on a wooden background, And that's the point, that the computer didn't know that what they were interested in was that bit, because most of this picture is light-coloured carpet. So when you showed it a picture of, most of these pictures are light-coloured carpet, so when you show it a picture of light-coloured carpet, it's going to say that looks like that. So then you get the kids to suggest how to fix it. Well, how could we make that work? So then they'll normally go for either, well, we need to mix up our examples, or we need to test it on examples of lemons that are only ever on a carpet, both of which are absolutely fine. When I was at uni, we were taught this. Has anyone heard of the Russian tank problem? No. Oh, I'm surprised. Okay, very quickly. Actually, I've heard several different versions of it, so it's almost certainly not true, and I don't know which one is the least not true. But the idea is that the story goes that the US military wanted to train an image classifier to recognize Russian tanks versus American tanks. So the team collected a load of photos of Russian tanks, and they went and took a load of photos of American tanks, and then they thought it seemed to work really well, and then they tried it out and it was rubbish. And long story short, what they found was their classifier, because they had access to American tanks, all their photos of American tanks were really high resolution, high quality, lovely photos. All their photos of Russian tanks were blurry, grainy, satellite spy photos. So what they trained was a classifier that can tell the difference between focus and blurry. But you can get the kids to do that and discover that for themselves. The other version of the Russian tank story I remember hearing is same sort of premise, US military project. This time it was recognizing camouflage tanks. So they trained a classifier to recognize a forest scene with a tank in it and a forest scene with no tank in it. And again, they took their photos, they trained it, they thought it was working well, and it ended up not working. And long story short, in that one, it was all the photos they took with the tank in was on a sunny day, and all the photos they took of just the forest scene was a cloudy day. And without realizing, what they trained was a classifier that can tell the difference between sunny and cloudy. So these kinds of stories that I remember learning when I was at uni, learning this stuff, as the maybe apocryphal tales of how to avoid overfitting, you can get kids to learn, but don't tell them that's the rule. Get them to try it out and learn for themselves. And the point is, particularly with the older kids, then you can talk to them about why things like this happens. When AI systems, high profile, famously get things wrong, you can start to have a discussion with them. Well, why do you think that happened? What led to that happening? In this case, if you're not familiar, this was a photo tagging system that recognized black people as gorillas. I believe it still isn't fixed. They've just removed that tag from their list. Recommendation engines are another interesting one. So at the basic level, you can get kids to train a recommendation engine, and you can sort of relate it to things that they may have used, like Netflix. So this one is, they're making a holiday app in Scratch, something that you tell it your hobbies and your interests, and it will recommend where you should go on holiday from the different tourist attractions it has. And if that by itself is an okay project. It works really well. They start to learn a bit about recommendation engines. But again, nudging them to get something wrong so you can have a discussion with them about it. Getting them to do something like this. Two similar places, theme park and fun fair. One with hardly any examples, one with absolutely tons of examples. Don't really call it out, but then let them try it. And then they test it, and they what can they do to make it answer theme park? Pretty much anything they say that's to do with adrenaline or fun or thrilling or exciting, it will say fun fair. Like, you can't get it to say theme park. So you sort of ask them, well, why is it? What they're learning about is bias. Very rarely will they suggest that as a word, but they'll get the idea. Just visually, they'll get it when they'll go, oh, well, we've told it I remember the way he explained it was, I've taught it that the answer is almost always fun fair, and I've told it the right answer is hardly ever theme park. Yeah, that's a really nice way of looking at it. That's true. But then you can start to have a discussion about ethics in AI with kids, because kids have a really strong sense of what's fair. And initially, you sort of ask them, well, what do you think? Like, say if I'd collected my training data by getting a clipboard and standing outside the theme park and the fun fair, and it turns out lots of people at the fun fair wanted to talk to me and no one at the theme park wanted to talk to me. Me as my mobile app AI developer, have I done a good job? And they're like, well, fair enough. Maybe you should, fine. And then you go, well, what if the fun fair owner paid me a big sack of cash, so I put loads of examples there and not in there? What do you think of that? And suddenly some of them are going, oh, hang on, money's involved. That's not fair. That shouldn't happen. But then there are still some that are going, well, it's telling me place to go on holiday, so really who cares? So then you go, well, what if this is an app being used by doctors to recommend medicines? And this is a pharmaceutical company that's paid me a sack of cash. So I've given it lots of examples of medical cases where their drug is the right choice, and hardly any examples of medical cases where their competitor's drug is the right choice. Now what do you think? And now most of them are off the fence and going, whoa, no, hang on, that's not fair. And the whole idea that that AI isn't about the smarter the technology, the more it gets right, as like an absolute thing, and the fact that who trained it has an impact, that what data they used to train it has an impact, the idea that these systems are only as reliable as the people who trained it and the data they used to train it, that's new to most of them. That's a penny dropping moment. That's this idea that, actually we should start to care about who trains the systems that we use. And maybe we want some transparency in for the really important systems in how they're trained. But to be able to have that discussion, that informed discussion with a room full of 12-year-olds who maybe didn't even realize this concept of biasing an AI system at the start of the lesson is really cool. So, problems with AI. So the main ones that are interesting to sort of play around with are overfitting and ethics and bias. So I'm running low on time, so I will wrap up. All of these examples that I've showed are on this site that I built, machinelearningforkids.co.uk. In hindsight, terrible name to choose. The younger kids take ages typing it in. And all of the projects that I've gone through, and actually several more I haven't had time to go through, are available as worksheets. So if you do have a son or a daughter or a niece or a nephew or a neighbor or a local school and you fancy giving them a try, it's all step-by-step instructions. They can build any of the things that I've gone through. So please do consider giving it a go. And it's not just me. There's other resources around that you should try as well. Google have got a couple of really cool ones. Teachable Machine with Google. Similar to what I've tried to do. I've tried to make it so you don't have to install anything. There's nothing to download. It's all in the browser. It's the same here. This one is training a neural net in the browser. You use the webcam and you can see in real time the different results that it can spit out. This one's a slightly old one, but another really cool one from Google. So this is, you're training a neural net to recognize shapes that you draw. But the idea is that this one is sort of like massive crowd-sourced training. So it's not just you training your own model, but you're contributing to something that the whole world is training. This one, I've never tried it. This one feels a bit risky, but if you're not familiar with this one is about self-driving cars. And the idea is that it gives you, the car is about to crash, something is going to go wrong. You have to make a choice between, in this case, should it hit the barrier and kill the driver, or veer off to the side, save the driver, but kill the passenger who is on the zebra crossing. So this is why it's a bit dark to do with the school. But I've tried it with my own kids. And it's really interesting because after you've trained it for a bit, after a certain number of examples, it shows you what you're teaching the computer. Maybe like things that you didn't even recognize or realize. Do you prioritize people over animals, healthy people over unhealthy people, people like doctors over other professions? It slowly and subtly and quietly gets them to think about all these issues. And this idea that, well, if cars are going to be driving, if AI is going to be driving the cars on our roads, what is the values system, the ethics system that they're going to have? Who should be training it? So it did enable a really interesting conversation, but if you are going to volunteer to go into a school and do it, it's maybe something, if you know the kids really well, that you're not going to upset any of them. So that's what I wanted to talk about. Why I think we should help teach kids about AI, teach them about how the world around them works, open their eyes to the fact that they're using machine learning and AI systems every day, and start to demystify it a bit, so it's not just this magic black box that they can ask questions to, but actually something that they start to think, well, I know how that works. I could have trained that. I could add a new skill to that. Particularly with the secondary school kids, get them to write their own Alexa skill and add it to, that's really powerful. They can actually see what they've made. And enable them to engage in debates like about self-driving cars, about how they think this stuff should be worked. How do they think AI should be regulated, managed, controlled? Who should be training it? Kids are up for that kind of debate if we give them the basic tools. And the other thing I want to talk about is to just show you the kinds of things that kids can build if you give them some simple tools. And all of these are just using sort of cloud machine learning APIs that are available to all of us as developers, but just wrapping it up in Scratch because it's a platform kids already know. So thank you so much for listening, and I think I've left 5 minutes for questions if anyone has any. Stunned silence. Oh, thank you. Yes. So for people who didn't hear, have I made the tool available in other languages? No, I'm working on it. Now, the machine learning models that it trains do support multiple languages. So when you're creating a project, you choose the language. And I've seen blog posts and videos from kids all around the world who've trained really amazing models. But the actual tool itself, I'm afraid no. But I'm going to fix that. I haven't got to it yet. Yes?
How do you link machine learning for kids and Scratch together to make it work?
So Scratch has... there's a variant of Scratch called ScratchX extensions. So they have a pluggable API to contribute new blocks. So yeah, I'm just using those APIs to contribute my own. And what you do, when I'm launching Scratch, in the URL, you tell it where to go and find the right extension. Now, the biggest thing I need to do, talking to a room full of developers, Scratch 2 is Flash-based, and that's a bit... We don't like Flash. It's actually a pain because there are a bunch of schools that are migrating to using touchscreen devices that don't support Flash. Scratch 3 that comes out in August is entirely HTML, JavaScript based. So as soon as that comes out, I need to migrate it across, and then it will be something they can do on iPads and stuff. But Scratch 3 also supports extensions and stuff. So either way, I'm just using Scratch APIs. Yes?
That must have taken so much time. What inspired you to actually do it in the first place?
Stupidly, so it was, why did I do it? What inspired me to do it? Stupidly, it was supposed to save me time. What I mean is, there's a school on site, the lab, the R&D lab where I work, just sort of on the outskirts, and I would go in and run, like the first one I ran was a Guess Who game. I got them to train a text classifier to recognize Guess Who questions and a face classifier to recognize facial characteristics. And making a bespoke training tool and a bespoke game engine took me ages. And they did that one activity, and then they said, oh, can we do another activity next week? It's like, no, I'll have to build another tool. So the idea was, well, if I make this generic thing, then the schools can just run it themselves without me there. But yeah, it didn't save me time. It's been worth it, though. I mean, at the moment, it's being used by 350 schools around the world. I keep getting sent videos and demos of stuff. Like a couple of the projects on the site were contributed by schools, by kids. Like there's a really cool one from Mountbatten School in Romsey. They made a face lock thing, so it uses it's facial recognition, and they've made a little mobile phone in Scratch that locks if it doesn't recognize your face. That's really cool, and I hadn't thought of it. So what inspires me and why I put time into it is that. I think it's really important that we do it, and I get a lot of buzz out of seeing the kinds of creativity and the kinds of things that kids are making. Yeah. So I've had more luck with primary schools than secondary schools. So I've done this with sort of like 7-year-olds and upwards, mostly because primary schools tend to have more time, like they have a bit more flexibility in the schedule. But I think this stuff applies across primary and secondary. I think different age kids get different things out of it. But I think at the basic sort of anthropomorphizing, getting the concepts, you can do with a 6-year-old or a 16-year-old. Yes?
How much effort do you have to put into getting the teachers to take it?
Not too bad. I mean, the main thing was, so I get a lot of feedback from teachers, and a lot of the design of the site came from teachers going, this bit's really hard, this bit's, So teachers are super busy. I mean, I'm married to one, so I know they're super busy. I know that if it's super complicated to install or set up or configure, they just don't have time for it. So, the kinds of thing I mean is, if you go to the site, you can try it out. You can't save a project, but if you try it out without registering, with 2 clicks, you can start creating a project. No personal information, no email, no registration. And that came from teachers saying, creating usernames and passwords, and the kids will forget the passwords as soon as I've given it to them, and then I'll have to reset it for them. So, yes, teachers do come with challenges because they're super busy people, but that has driven the development of the site to try and make it easy for them. But I'm sure there's still more I need to do. I'm out of time now, so thank you so much for listening. I hope that was kind of interesting, and enjoy the rest of the day.